But yeah, the reason you're all here is we'll be talking about GitHub Actions, which essentially provides tools to let you automate tasks in the cloud using GitHub. And there's a variety of different ways that you can do this, and a bunch of different types of workflows. So here's the kind of this diagram on this website that I put together on the landing page, where one example is you're just collecting data in the field based on remote sensing from satellites, from data that you went out and collected yourself, from tags, from anything, and or even like simulating data. And then you want to process that data in some format. Maybe you want to make predictions from a model you previously fitted, something to that effect, use quality control on your data. And this is all done in the cloud in GitHub. And then based on that processing or prediction or whatever, that task, then you want to visualize these results in a report or a dashboard, or you're creating software that are then going to be used by other people in some kind of research workflow. So this is kind of a potential way that GitHub Actions could be used in scientific research and software development. Is primarily how GitHub Actions is used originally. So just providing some background, just prerequisites essentially. So this workshop is going to be more me discussing topics and demonstrating these concepts. It's not going to be as hands-on, just because different people are going to have different things set up, and it would just take a lot more time. So we could potentially do that in a separate meeting or a workshop, but this is going to be more me just talking about these concepts and how to put everything together to get things working. So essentially, I'm assuming that people have basic coding experience in some programming language. That could be anything. The ones I'm primarily focusing on for this workshop are R, Python, and MATLAB. All of those could be used in a GitHub Actions workflow and more. I also assume that people have a basic working understanding of Git and GitHub, and that they have an account, because that's kind of needed to then be able to apply these tools. For those that maybe don't use GitHub regularly, or haven't in a while, or haven't at all before, I have a link here that's kind of like a recommendation for learning how to use Git and GitHub. So the focus here is specifically for R users. It's this ebook that I have linked here by Jenny Bryan. But a lot of the content in it is agnostic of programming language. So it's still really valuable and useful, I think. But there are more examples that are focused on R specifically. And then I also ran a separate like intro to Git and GitHub workshop, primarily using RStudio a few years ago, that I recorded and uploaded as a YouTube video. So that's also linked out here. And then beyond just this single workshop today, I have a discussions page that I have linked on this homepage here that I'm showing, that you could essentially drop in any questions you might have, and then I'll try to answer them and get to them when I have time. But this is on the GitHub repo associated with the workshop in this website. So you can access that all from the repo or the link on this website here. Okay, so the way I'm going to try to run this is essentially go through different sections here that are shown on the sidebar, and then maybe pause briefly just to check if there's any questions. So feel free to add those in the chat, and then I'll try to get to them during these breaks. But essentially, I'm splitting this up into the first half, the first hour. We'll be focusing more on like the basics and concepts and understanding what are GitHub Actions, how do you write them, how do you just set it up, and then the second half, the second hour, is more focused on like specific use cases of like how do you actually use this in a real world example. So that's how I'm going to try to split my time, and then might have to skip things or speed through things depending on how fast things are going. So that's the plan, but feel free to ask questions as needed, and I'll try to get to those. Okay, so before diving into the actual material, I just want to provide a few motivating examples that will hopefully help demonstrate how GitHub Actions can be used in different scenarios. So I have those listed here, all at the bottom left here of this sidebar. And some of these were kind of contributed or requested by some of you. So this first one was requested by Mike. focused more on MATLAB. So in this particular example, this is just a Corda website that I built. And the particular code that I'm using here is a smallish not R script, a MATLAB script, where I'm accessing ROM sea surface temperature data from the OpenDAP server. I'm summarizing it, so taking the mean value for the Southern California bight, and then essentially adding this value to the end of a CSV file. That's then pushed to this GitHub repo, and then we can visualize the results. So the GitHub action workflow file is running in the cloud in the background, and then now this website is showing the results of that GitHub action. So here's just a small table showing mean sea surface temperature for that region per day. So ROMS is down at the moment, but this is showing the last 3 days that it was available. And then you can also plot that or do whatever you want with it. So just showing a simple example of how this could be used. I'm not going to go into the details of the actual file, but this is what the file is essentially giving the instructions and commands to run these steps in the background. And we'll be digging into what that looks like and what that means. And this is associated with a separate MATLAB script that's shown here on this right sidebar, and then the CSV file that's created each time. Additionally, you can have different output formats too. So in this case, this is more a Corda thing than it is GitHub Actions, but you can also have a PDF of this like report, this website created as well. So this might be really useful for folks that have to make reports semi-regularly, and that you're sharing these results with people, and this is kind of an automated process for you. That could be both like this HTML format and also a PDF format, all in one place. Okay, so that's kind of one example. Another similar-ish example is essentially a dashboard. So in this case, this is a dashboard in Corto, but it's essentially made with R, but the underlying data that was collected for this was written with a Python script. So this is accessing Ekman upwelling data from ERDAP and extracting it for the ramp zones along the west coast of California here. So this is summarized per month per ramp zone. This is only showing 6 of the 7 zones for the last 9 months. So this is like a mapped version that's showing the aggregated kind of means per zone per month. We can also look at this as like an interactive plot, an interactive time series as a plotly plot. Then there's this table here on the left side that, again, I can like expand and filter, I can export, I can do whatever. So that's completely separate from the GitHub Actions, but the GitHub Actions is what's updating this constantly. So in this case, I have this updating once a month, essentially, because it's monthly data. And this is associated with its own separate workflow file in Python script that's actually downloading the data and things like that. Couple others. So there's this validation one. I'll just kind of skip that for now. But then some more like separate examples that are not created specifically for this workshop. But one is kind of a proof of concept operationalized species distribution model. In this case, for a leatherback model using Copernicus Marine Environmental Monitoring System data, or CMEMS data. So the GitHub action is running in the background to make model predictions every day, and these predictions are shown as these, essentially these images. So this is showing the latest 4 images. So one from yesterday, and then the day before, and then so on. So this is only showing 4 of these products, but below this I've embedded a Shiny app that's then pulling in environmental data and model predictions that could then be interactively explored here in this embedded map, essentially. So that's for the predictions, and I could change the day on this if I wanted to, back to, let's say, like sometime in November. I could also change this to look at environmental predictors and look at the values of these. So this is for primary productivity, and let's say I want to look at that for late November. So if I hover over this, now I can look at the actual value of productivity. And this is all pulling in data from the GitHub repo into the Shiny app, which is embedded in this website. But what's powering all of this that's updating it is these GitHub actions. And one other one I want to kind of bring up is this website created by Lynn DeWitt. That's this CCIEA website that's essentially updating daily based on additions to a Google Drive folder. So if people are adding their own data to this Google Drive folder, it'll check it daily and then make updates accordingly. So if you're exploring this and filtering things, you can see what's available. And this is, again, kind of powered under the hood by a GitHub action. All right, so that's kind of some motivating examples of how this could be used. So you're not seeing the action itself, you're seeing the product resulting of the action running, essentially. So to get into kind of the basics of like, how do you define a GitHub action workflow and what are the different components of it? How do you set one up? So all in all, I think of GitHub Actions as kind of this modular automated workflow for performing different tasks. This could be project management within a GitHub repo, or it could be operationalization of a tool. So they could be used in a variety of different ways, and I'll be exploring some of these as we kind of go along here. And some features that I wanted to kind of highlight that could be used in different ways, whether it's for scientific research or more like software development, include some of these. So one feature is a variety of hosted runners, and I'll define more what runners mean, but essentially it could use different types of operating systems. So in this case, the options available include Linux, Windows, and Mac. And there's different benefits and drawbacks to each of these, but in general, the default tends to be Linux, which presents its own sets of challenges. Additionally, you can use essentially any programming language you want. Some are installed by default on these runners, on these operating systems. Others aren't, so you have to install them yourself, which isn't super difficult depending on which one you're using. You also have what are called live logs. So essentially, when you're running an action, it'll print out updates to what it's doing, what software it's installing, what actions it's taking, and you can watch all that unfold in real time. So especially if you're trying to debug something, you can see where the error occurs, what the error message is, and then fix it and move on from there. It's not super black boxy or anything. For the most part, it's pretty easy to look under and see like what it's doing, where it failed, and how it's working, which is really nice. You can also store essentially authorization credentials or tokens. So these are called secrets for GitHub Actions. So you might have heard of tokens before for like an API, or maybe you'll use like a username and password as like your credentials for something. So instead of hard coding these in, which might expose you to like security breaches essentially, you can store these as secrets so they're not kind of unveiled to the public or other people that shouldn't have access to them. There's also things that probably more focused on software development, but matrix builds, so you can test software, run things on a bunch of different types of configurations. So you want maybe to test across different operating systems and versions of software or something like that. And then the last really nice feature is it's highly affordable. So for basically all the examples I'll be showing today, it's free, especially if you're using public repos on GitHub. There's other higher performance features that are available that might be only available on enterprise accounts, or that you have to pay for that isn't just covered, but you have a lot of like free time essentially in the cloud for doing things. So especially for kind of more simpler, like standard tasks, this is really convenient, and you have like a monthly allotment essentially. And I describe some of the limits here and caps on things below. I won't be discussing them in detail, but you can look into that more if you are interested. Okay, so that's the features. Now I kind of want to talk about let's break down like what a GitHub Actions workflow is and what are the different components of that. So kind of big picture here is our GitHub Actions workflow. This diagram I pulled from offline. So we essentially start with some event that we can define ourselves that will trigger a workflow to occur. And this could be a variety of different things. We can have this scheduled to run at some frequency. We can have some events through Git and GitHub that occurs that then causes this workflow to run. We could have one workflow that triggers another workflow. It could be related to all types of things. So in this case, we have some event that occurs that triggers a workflow to happen. And a workflow is essentially storing essentially the virtual machine that'll be running whatever tasks we want. So in this particular example, this workflow is comprised of 2 different jobs. And then within each job, we have a runner, which I mentioned before, and I'll discuss in a little more detail in a second. But just think of that as a server or an operating system. So within each runner or each server, we have a set of actions or steps that occur to then do this task or set of tasks. And we can have this essentially cascade sequentially, so the completion of this job then triggers another job within a single workflow. So that's one way that this could be set up, or you can have just a single job. There's a bunch of different ways this can be kind of created. And all of your workflow files that you create to do your tasks will essentially need to be stored in this directory here that I have in purple. So it'll need to be stored in a .github/workflows directory. And that's where GitHub is going to be looking for these files. If they're not there, it won't detect them, and then it won't run. So I'll show some of these examples a little bit later on, and how to make sure your files are within that directory. Okay, so that's just an overall kind of summary of what is in a workflow. But now let's get to the events. So the events are what trigger a workflow to run. So like I said before, there's a variety of different events, but there's, I think, only a handful that are probably the most common that you'll be using for different kind of scientific purposes. And these, I think, tend to be pushing a commit. So if you've used GitHub before, the whole thing kind of behind version control is you make changes to stuff, you make a commit that says this is what these changes are. You might pull down from your remote repo in the cloud any other changes that occurred before, and then you push that commit, those changes, to the cloud where the rest of your code and data is. So when you push that commit, that would then trigger a workflow to happen if you set that as the event. Additionally, you can have it essentially run at scheduled times, essentially using cron jobs. So let's say you want to have the workflow run daily at 6 a.m. You could schedule that, or you could have it run every other day at midnight, or something to that effect. So there's different ways you can set up either the time or the frequency with which these workflows are running. Or you can have it basically be triggered by the completion of another workflow or another job or something. So these are all different ways in which you can trigger a workflow to happen. And these can also be basically combined together. So you can have multiple different events. So you can have a push trigger workflow as well as have a scheduled time trigger of the same workflow. And I'll show some examples of that in a little bit. And for more examples of all the different types of events you can use, I link out here to the actual GitHub page that has more documentation about this. Okay, so that's events, but now we have the jobs, which is kind of the main workhorse of defining what goes into these tasks that are being run, or these steps. So again, the job is essentially what's storing or holding the contents for this server to run things. In this case, for that diagram, this is showing 2 different jobs, but the simplest is just showing a single job. So let's say all the set of steps we want to perform are shown in this diagram here, this pipeline. So this might include checking out or cloning your repo, so pulling in all the contents of it into this virtual machine where your GitHub action workflow is running. Then let's say you want to install R or some other programming language software, the dependencies, the packages that you want to use, and then you want to do some things. So you want to run the R scripts you created, and then after running those scripts, it's maybe writing files, it's making changes, and you want to commit and push those changes back to your repo, because those don't happen when you're running them in the virtual machine, essentially with the GitHub Actions workflow. Think of that as like a separate entity. By itself, you need to push those changes back so you can actually see them and use them later. So what I'm showing here in the green is essentially what can be used as these essentially pre-made actions that are available for you to use. So it requires very little code. That's essentially like a function that does a bunch of things for you in a very compact manner. So if you were to click on each of these, I have those linked out to the actual action that's doing that task. So like on this first one, check out the repo. This is essentially one of the most common actions available that you will use. and it provides more documentation and stuff here. Same for these other ones, like installing R or R packages. You could click on those if you wanted to explore that more. So you can set up a job in different ways. This is just kind of one simple example of how that can be done, which includes all these different steps. So like I showed before, the job is essentially kind of defining this bigger picture, and then within that you are hosting all of the code and software on a runner. So a runner is basically just a server that is housing this virtual machine, and that can be running different operating systems. So whether it's Linux, Windows, or Mac. And like I said before, there's different benefits or drawbacks to using each of these. But you're essentially provisioned a certain number of like free minutes or like usage of GitHub Actions. And it tends to be cheapest, or you can run it for longer if you use Ubuntu, so like Linux versus Windows or Mac. Windows is essentially the next best option based on like how much it would cost before you like run out of free minutes or free usage. And then the most expensive would be Mac. If you don't have like a credit card on file, like you won't be charged for this. Like you can have it set where if you were to use this, but you use a lot of minutes, it'll like basically stop working once you've reached like your allotment. So I'm not going to go so far into the details about like what's available and some of these specs, but you can look into that more if you are interested. But in general, I haven't really had an issue with this in my past experience. But some of the like hardware specs essentially on these servers that you would run for the runners, in general, the standard option that's available, unless you're like, changing things, is they'll offer about 4 cores for the CPU, about 16 gigs RAM, and about 14 gigs of storage space. And you can use different versions. So there's either like the latest version that's available for each operating system, or you could even use older versions if you specify that as well. All right, and then the last major component of a workflow are the actions or the steps that are within it. So like I showed in this diagram, these are kind of like each of the different steps that is like doing a thing. So like installing software or running code or doing something like that. So I show here that these are like essentially pre-made tasks if you use a action. So one of the most common, like I mentioned, is using checkout. So that's essentially cloning or like fetching all the files in your repo. So without doing that, you don't have access to any of those files, any of the code or data or whatever you have. So you need to do a git checkout essentially to be able to get all those files into this virtual machine on the runner. Next, you might need to install software. So Python's already automatically installed on these, so you don't need to worry about that. But if you want to use, let's say, R or MATLAB, that's not automatically installed. So you need to use an action to then install R, which makes it way easier than like coding that on the terminal. Same with R packages. There's like a quick and easy action for doing that as well. If you're using Python and you like to use Conda for creating virtual environments or installing packages, the easiest way to use and access that is to install Conda using an action. Additionally, if you want to make Cordo documents, you would need to install Cordo, and then you can also use a separate action to publish documents, whether it's a dashboard, a report, or a website, or whatever. So these are all like pre-made actions you can use. Additionally, you can run stuff from like the terminal or command line if that's of interest as a separate step. I have brief notes here on high performance computing. This is more like pay for play. You might have some more options that are available if you have a GitHub Enterprise account, but in general, these aren't things that are like freely available for use. But I do have that here for those that might be interested. All right, so that is it for kind of just overall basics. And what I'll be covering for the rest of this first half of the workshop are kind of like the simple parts of setting up a GitHub Actions file. So kind of the main kind of learning outcomes here is learning the different components of a GitHub Actions YAML. So these workflow files are using a YAML file type. So for those that use R Markdown or Corto, I don't know about Jupyter Notebooks, but usually you have some type of like YAML header in those. So like in this case, we have an entire YAML file, not just a header. And that's what's going to give you the instructions and directions for running this GitHub action workflow. We'll also learn how to add different steps to install software, to do things, to fetch all the files from your GitHub repo, to then do other stuff. And then the last component of this first intro piece is using different types of events to trigger workflows to run. So then I'll be finishing with that for this kind of first half. But I think I'll pause briefly to see if there are any questions on just kind of the overview of GitHub Actions before kind of diving into some of the details. Okay. Well, then I will press on. All right, so I have this section called Anatomy of a GitHub Actions YAML. And I'm going to try to spend more time here because this is going to be the foundation that then we'll add more complexity onto later on as we keep building. So I have a lot of notes that I'll be kind of brushing through briefly just because there's a lot to get through. But feel free to add questions in the chat or stop me if needed, and I'll try to answer questions. But like I mentioned, we're essentially setting up a GitHub Actions workflow using a YAML file. And there's a specific set of syntax that we need to use for doing so. In addition to just the syntax, there's also the structure. So for those that use Python, it might come a little more naturally where the indenting matters in terms of how the file is run and interpreted. And that's very much the case here, where if you don't get the indentation correct, it will fail and not work on you. So we definitely need to be careful about that, and I have stuff kind of set up here that's supposed to be indented properly. So that's just one thing to be aware of if you're starting to create your own GitHub YAML files. But here's just a really simple example, and I'll kind of walk through some of this. If you were to do stuff on your own and maybe want to copy this code, these are all just different code boxes, and there's a symbol here that you can copy this to your clipboard and then paste it somewhere in an empty text file or something. So here for this file, I've named this example simple.yaml. That's the name of the file, and then within the file, here's all the contents kind of defining this workflow. So optionally here for one, you can give it a name. And I would say best practice is to give it a name, because otherwise it's going to be hard, especially for a bunch of these, basically what this is supposed to be doing. So in this case, I call it test GHA for test GitHub action. And then right below that is another essentially argument here that we're providing that's called on. And on is essentially where we define the events that trigger a workflow to happen. So in this case, I'm defining the event as push, meaning essentially if I make a push to the repo, then that's what's going to trigger this to run. So if I was to make any changes at all, I'm adding a new file, I'm deleting a file, I'm changing a file, and I push it to the repo in the cloud, then this stuff will happen. So this is only one example of how this would work. Then moving down, we have another argument, kind of the first level here of the hierarchy, called jobs. So this is now where we're going to give all the info defining the job that we're going to run. So I mentioned before we have the jobs, and then that's within a workflow, and then within that are the runners, and then the actions or the steps that are actually going to be run individually. So we use the syntax jobs here, and then we indent once, and then we start adding more components. So for this next line beneath jobs, that's indented once, and then we have text here. So in this case, it's kind of confusing, but this is essentially a custom name that you're giving to the job. So instead of the name for the entire workflow that we defined here at the top, test GHA, now we are essentially giving a name to the job, but there's no name argument. You just write the name. And in general, it shouldn't have any special characters. So essentially it should separate text with either underscores or dashes. So no spaces, no other stuff. In this case, I'm calling the job test_job. It could be anything though, but ideally relevant to what the job should be doing. So in this case, I'm using test job. This is just a test GitHub workflow job. And then make sure you have a colon at the end of that. And now we're adding more content. So the next line, once we've given the name to the job, is we're defining the runner. And the way that we define that is we give this argument runs-on, and then colon, and then the name of the runner. So here I'm saying I want to use the Ubuntu latest runner. So it's using the Ubuntu Linux operating system and the latest version of it that's available. This could be Windows-latest, this could be Mac OS-latest, or you could do like Ubuntu- an older version name. So like 22.04 or something. That's where you define the runner that you want to use as your operating system. Once you've done that, beneath it is where we define the steps for the different tasks or actions that will occur. So we have steps here, colon, and then similar to jobs, this is now going to define the steps. And then we add a dash to kind of denote the next, like each individual step. And here in particular, I note here for step 5 that this is optional to provide a name to each step. You could only use this uses argument if you wanted to, but I think it's easier to follow along and understand what's happening when you're looking at GitHub YAML files if you give it a name that says what it does. Although it takes up more space, it's easier to follow and then debug later on if you have issues. So I'm defining this first step as checkout repository, and it's using this pre-made checkout action. So it's using this argument called uses, and then essentially this is the syntax for defining where the pre-made action is coming from. So it's actions/checkout is the action itself, and there's different versions of these that constantly get updated. So I think there's even a version 6 that was just released recently. But when I was creating all this content, version 5 was the latest, and even that was new. So to provide the version, which is essentially necessary, you would have the @ symbol at the end, and then V5 in this case for version 5. So if you're making a new one, you probably want to change this to V6, because that's the latest version available. So this is going to essentially pull in or fetch all of the files from your GitHub repo and pull it into this virtual machine to start doing stuff. So once you have access to all those files, now we can do other things. So this next step, again, this is just a simple example just to show how it works. Again, I'm adding a dash and then providing the name in this case. So I'm listing the files in this repo that I now pulled into the virtual machine. And now I'm using this other argument called run. And run is essentially just running commands from the terminal. So in this case, by default, especially for Ubuntu, the default terminal tends to be bash, like a bash shell. So in this case, if you were to run ls, that's telling it to list all the files in the root directory in that wherever you are. So in this case, in the virtual machine, it should print those out for you. So that's what essentially this simple GitHub Actions workflow is doing, is if I push a change to the repo, it's going to, on an Ubuntu server essentially, pull in all the files from the repo and then print out all of the files from the root directory. So that's essentially how we're setting up this YAML file to do stuff for us. And again, the indentation matters and is very important. And like I mentioned previously, this file, so the simple.yaml file, would need to be stored in this set of folders .github from the root directory, and then /workflows, so this subfolder. And that's where you'd put these files. And one thing I want to note is that the folder names that begin with a period or a dot tend to be treated as hidden files or folders, so you won't necessarily be able to see them if you open up like a Finder window or Finder some pane or something. Even though you might be able to see them in RStudio or Positron or VS Code or whatever you're using. So if I go over to RStudio, just as an example, I have my files showing here in the bottom right pane, and I have this .github folder. So if I click on that, now I have this workflows folder, and then within that are all these YAML files I created for this workshop. But if I was to open up my Finder window for my computer and then navigate to this project, you don't see it. So unless I was like specifically like allow or visualize view hidden folders, I can't see it here, so I can't necessarily like drag and drop stuff in, which is kind of annoying. So one thing I'll mention beneath this is you can just use code if you need to move stuff around, essentially. So if you created a file, so let's say in RStudio, if I create a new file, and I'll just make this a text file because there's no YAML option. So I'll write test.yaml, and that should make a new YAML file for me. And I'll just like template GitHub action workflow. So I won't even add any other stuff in here. I'll just have this commented text out. And I'll save this. So this is in my root directory. You'll see it's here at the bottom, but I want to move this. So for RStudio, there's options to have this do it for you. But if you go to the terminal, let's say I copy this code and I'll just modify it. So using the mv command for move, I'm going to move this test.yaml file to this directory, which is .github/workflows. So if I run that, now it's saying the file's moved. Do you want to close it? I'll say yes. And now I'll navigate to that in RStudio. And now we see it here at the bottom that we have this test.yaml file. So that's one way you can add it in if you can't easily add it otherwise to this directory that you need. But for now, I'm just going to delete that. Okay. So that's for just getting this set up and storing these in the correct folder. Now, once you've done that, you'll want to push these to your repo online in the cloud. And then we can kind of look at these in more detail. So if you were to go to that repo page, so I'll just pop over there here. I can probably drop this in the chat also. Here you'll have your repo, in this case my repo, and if you go to this Actions tab at the top, it'll list all of your different workflows you created that it auto-detects on this top left part of the sidebar. And in this case, it kind of truncated it because there's just so many. So if I click Show More Workflows, it'll show the rest of them. And then, assuming once you start running workflows, it'll show the history here, essentially, for the workflows that you ran, and then the status of that workflow. So in this case, a red X means it failed, a green check mark means that it succeeded, it worked correctly. And if you see something that's like amber, an amber circle, that means it's in progress. And I'll run some live examples of this just to show what it looks like in a little bit. But this is where you would go to look at and find your workflow files. So like, let's say I was to click on one of these. This is only focusing on this one workflow. And then you can look at that in more detail. Likewise, you can go to a different workflow and it'll only focus on that one workflow compared to the whole list of all the different actions workflows that were ran. And we can see here that there's this .github/workflows directory I can click on. And this is what has all the YAML files that I committed and pushed. Okay. So that's described in a bit more detail here on this webpage, and I essentially covered all of this. So if you were to click on a workflow, that might give you more details. So this MATLAB example that I show here. So if I go back, click on MATLAB example, and the past few failed because of issues trying to get this one ERDAP data set to work and download. But in general, it typically works most days. So if I was to click on, let's say, one of these that did run, there's two different jobs here. The first job is called MATLAB test, and then the second one's update website. And if you were to click on these, it'll give you more information. So this is all kind of essentially condensed here, but if you were to like expand it out, there's like run script, and it has a little bit of like a printout here, or set up MATLAB. So in general, this one's a little bit shortened, but you can look at more of the details here, and it tells you how long it took to run, total duration, things like that, which is really nice and useful. Okay. Just more general info about this stuff, and I kind of showed some of this, just expanding that workflow a bit. And just as a tip, for all these pages, I linked out different resources here on the right side under this table of contents. If I have other documents or links here, so for the simple example YAML file I created, that's linked out here. So if you click on that, then it shows all of the runs from that particular workflow. So because it's on push, anytime I push to this repo, it runs, whether I wanted to or not. So if you to click on this, then all it did is list all the files. So here's all the files listed from the root directory. So that's what it looks like when it's run and did this task, ran this command. But there's, for some of these pages, a lot more files linked here when I'm showing a bunch of examples. Okay, I will stop there for the moment before I move on to the next page. Does anybody have any questions about kind of just how you set up a workflow file in general? Yeah, Kurt.
Thanks, Josh. Are there any kind of best practices for how to structure how many steps you might put in a particular job versus kind of compartmentalizing various jobs?
Yeah, as far as I'm aware, there isn't. It's kind of like when you're creating a script that you could break up code into like 3 scripts, or you could potentially stick it into 1 or 2. It's kind of where natural breaks might be. Or let's say you want to run up to a certain point, and then you want multiple jobs or multiple workflows to then trigger another workflow. So then it might make sense, like say, okay, like in this case where I have all these different actions, I want the website to update based on maybe different workflows or jobs. So I don't want each workflow to have to update the website separately. I'll write one file to do an update website run, and then like download data or update document or do whatever as the separate initial pieces. So it's very much case by case, and I kind of talk about that a little bit later on. But yeah, there's no, as far as I'm aware, best practices as which way you should do it.
Okay, thanks.
Yeah. All right. Isaac said, "Can you have a GitHub action as a GitHub action?" In a sense, if I'm understanding this correctly. So one thing I briefly show later on is you could have a GitHub action workflow that triggers another GitHub action workflow. So let's say you want to run one thing, and if that thing completes successfully or fails, depending on the outcome, it'll trigger something else to happen. So that's an option of something that you can do, assuming I'm answering yes. Okay, good. So I'll briefly talk about that a little bit later, and I have some examples of my own code where I've done that. But yeah, you can string these together in all sorts of ways, or have them run independently, concurrently at the same time, if they don't need to be dependent on one another. So there's all types of ways these can be combined. Okay, cool. So we'll move on to the next section, which is adding more steps. So at this point, all we've really done is checked out the repo. So we just pulled in all the files, and then in this case, we just printed listed all the files out. So that's super basic, but now we can start adding in more complexity. So what are other things that you should do in other workflows? So I have a bit more content on this slide, and again, resources linked out to the right side for some of these different YAML files. But some of the easiest ways to do different steps is to use pre-made actions. So I showed before, you can use the action/checkout GitHub action that's been made by other people. In addition to pre-made actions, you can also essentially run code from the command line. So like I showed before, you can use the ls command from the shell from the terminal to then list all the files, and you can obviously do much more from the command line. So you can do stuff like that in a GitHub workflow. Alternatively, let's say you want to do a bunch of stuff from a different type of programming language too. So you create a script where you're doing your analyses or making your predictions or processing data, but you want to run those scripts instead of adding all this to a huge workflow file, because that's unnecessary. So you can then basically run whatever scripts you have from the workflow and tell it to run those. And again, those could be in any programming language essentially, but what I'll be covering today are R, Python, and MATLAB. So it's all up to you in terms of how you put these together. You can even combine programming languages if you want to. And I even show some examples of that as well. Okay, so to start off, just using actions to just install software for you. So this is kind of the simplest way to do it, rather than having to do this custom yourself. So again, like I mentioned, Python comes pre-installed on all these different runners. So luckily, if you're using Python, you don't need to worry about installing this yourself, although there are options if you want to install older versions or newer versions than what's actually available. But for R and MATLAB, those are not just available out of the box. You need to essentially use an action to first install them before you can use them. So here I have some examples of the same workflow file, just in a different programming language. So for R, I have this workflow, and I'm giving it the name of the workflow as R installation. And then now a slight different change here for on. So again, this is our event that's going to trigger the workflow to happen. I'm saying I want this to happen on push like I did last time, but here I have this on a new line with a colon at the end and more stuff afterwards. So you can add filters essentially where you're specifying, let's say you have multiple branches because you're doing software development, or you have a development branch and a main branch and something else, but you only want this to run when you push to the main branch. That's what this is saying. So for those that only have a main branch, then this is essentially redundant. That's extra detail than is needed, but it may be useful for some folks. So this is essentially running the same thing we had before on that same trigger. And now going below that to jobs, now I'm calling this job R_install. Again, we can name this whatever we want, but the purpose of this example is installing R. So that's why I have this name. Again, I'm running this on Ubuntu latest. That's the runner. And now for the steps, again, I'm using this checkout action. For the first step, that's, I think, standard protocol is you check out the repo because you need to pull in all the files. Next, once you've done that, in this case, I want to install R. So I'm giving it this name beneath it, install R. And then uses is where I'm specifying the action. So the kind of R development team created a bunch of these different actions for doing different stuff. And these are available at this r-lib GitHub repo. And within that, they have a whole list of actions. So this first one here being setup-r. So that's what's going to install R for you, regardless of which operating system or which runner you're using. It detects it and then knows how to install it properly. In this case, the latest version is version 2. So that's why I have at v2 here. And if that's all you included, it'll download and install the latest version of R. But for some people, that may not be what they want to do. Let's say you want to use a specific version of R that plays nice with a specific R package you want to use or does whatever. You don't want to use the latest version necessarily because that's going to continually change as they continue to update. So in this case, I'm showing how you can specify which version you're interested in. So if you use this argument with, that allows you to list out these different options. And then beneath that, I'm having this indented argument r-version, which is where we specify the version here in quotes 4.4.3. So I think the latest version that's available is either 4.5.1 or maybe something a little bit later than that. But let's say you want an older version, that's how you can specify it. So again, this is a very minor, small set of code that just installs R for you where it didn't exist before. So that's really convenient. And I link out here to that GitHub repo with all of these actions for installing R packages, all kinds of stuff. So you can explore that more as needed, and tells you which different options are available for you to specify. Alternatively, for Python, here this is focused more on a conda installation because Python's already installed by default. Most of this stuff at the beginning is the same because these are all supposed to be like parallel examples, doing the same type of thing just in different languages. So in this case, the job name is now conda install because now I want to install conda, not R. We're still using the Ubuntu runner. We're still using this checkout action. But now instead of installing R, I'm now creating a new step called install conda. I'm using this action to essentially install miniconda. And then I'm specifying the version here and then providing options using this with argument. So things like auto update conda is set to true. I'm specifying the Python version here also. There's different versions of Python available on each runner. So let's say in this case you want to use 3.12. You could also specify 3.13 if you wanted to. But in this case I'm being explicit about which version I want. And again, that's linked out here to look at more of these options and details. And then lastly, for MATLAB, again, most of the stuff at the top is the same. We're just changing the name because we're working with MATLAB. And I'm changing the name of the job to MATLAB install instead of conda or R. Again, Ubuntu runner using the actions checkout, GitHub action. And then now we're setting up and installing MATLAB. So we're using this uses MATLAB-actions username, and then setup-MATLAB is that action to install it. And again, we can specify under with different options. In this case, you might want to define which version of MATLAB. So you could use like this version R 2024A if you wanted. So that's not the latest version, but that's a semi-recent version. And there's more detail here that's more MATLAB specific. And from my experience, I found it to be a little more finicky for doing stuff, not necessarily installing MATLAB, but certain versions of MATLAB might not work as expected. So I think best practice might be to just use the latest version available, unless that's not working for you for some reason. Additionally, another note here from MATLAB users, these MATLAB can only be used from a GitHub action if it's on a public repo. If you have a private repo, by default, it's not just available. However, there is options to do that if you use these MATLAB batch processing tokens. So essentially, if you have a license for MATLAB on your personal computer, you should be able to then like use that to get a token to then run this on a private repo. If you don't necessarily need it to be private, it's probably just easier to just use a public repo to do this. But I have links here to look into that more if you're interested. But that's kind of the one kind of caveat here with trying to run MATLAB in a GitHub action, is it should, for most cases, probably be public to work properly. Okay, so that's for kind of using basic pre-existing actions for installing software here. So installing R, Conda, or MATLAB. But now if we want to install different dependencies or packages, that's a separate step. So some examples here, like I'm showing, maybe you want to install different geospatial packages and libraries for handling raster data, or you want to install things like SF or GeoPandas in R and Python for handling vector spatial data, all kinds of things. So this can all be relatively easily done, but it differs per language, and there's a bunch of different types of options available. As far as I'm aware, for MATLAB, this isn't as much of a thing, but for R and Python, it does need to be more explicit. And at least from what I found, since I'm less familiar with Python than R, is that R tends to have way more potential options to do this versus kind of what's standard for Python. So for R, to install packages on this virtual machine in your workflow, you can either create a description file and then list them all out there, which is pretty normal, more for an R package, not like just a standard GitHub repo. You could also use the rm package to do kind of version control of your packages. And this is kind of used for you by default in the cloud. But I've had some issues in the past with geospatial packages having GDAL installed properly and all these other things. Then now I've tended to avoid using rm necessarily, although that's kind of still almost like a best practices thing for reproducibility. Alternatively, you can run the install.packages function just from kind of the command line if you wanted to install it manually that way. But there's also an action that's created, a pre-made action that then you can either tell it which specific packages you want to install or it auto detects them for you. So like I mentioned, there's just a ton of options to install packages for R. So it's kind of choose which way works for you. For Python, there tends to be kind of like one standard, and that's to create a requirements text file. And that lists all of the different packages and dependencies you want in a single text file that's then read in, and then they're all installed for you. Alternatively, there's this tool that I found called Poetry that works kind of like for R as rm, where it creates a lock file and like kind of version controls these packages, but I'm less familiar with that. So I found that the requirements text file tends to be the simplest, the most widely used, and the most straightforward. I noticed there was a message in the chat. So from Heather, have you run into any bugs with installing geospatial R libraries? I have when using rm, whether it's with a GitHub action or deploying Shiny apps. For whatever reason, it might not use the right version of GDAL, or it doesn't install it properly, or it has other issues with like compiling code if it can't use the binary package files. So in general, I avoid using rm for installing packages where I'm using geospatial stuff. If you're not using geospatial libraries, that's probably a way easier approach. But I'll show other examples later on where we're installing packages and I won't be using rm, but we'll be using geospatial stuff. So it is relatively straightforward, and I haven't had really any issues with it with existing workflows I use. Okay. So beneath this section here for, again, specifically R and Python are some examples of these files for how you can define which packages you want to use. So like I mentioned for R, one example is to use a description file. Again, this is primarily just for R packages, but you could still use it for just a normal project. So the quickest way to make one, or easiest, is the use description function from the use this package, because it already has stuff kind of set up and formatted for you. And if you try to make this yourself manually as like a text file, it hasn't worked for me in the past sometimes. So it's just easier, and it will work if you use that function. And it requires certain information that you provide up front, even if you're not making a package. And then you would just list all of your packages you want to import or install at the bottom here. So that's what you would essentially do if you go that route. Again, there are different options and different ways to install R packages. This is just one example. Alternatively, for Python, the easiest way to do this is to, within your virtual environment or project or whatever you're doing, is to use the command pip and then freeze, and then essentially using this like pipe operator, where you're saying like all the contents from freeze, we're going to store in this requirements text file from your root directory. So that's where it's going to be stored. And this is essentially what the contents might look like based on what packages you're using in your Python scripts. So you'll have a list of packages, and then for some of them, they might also have some type of syntax here, in this case saying, so like the first one, GeoPandas, $=1.1.1, meaning you want to install GeoPandas specifically for version 1.1.1. This could be changed so you could have this be greater than or equal to. So it might install a more recent version of GeoPandas. You can also not have anything after the name of the package, like at the bottom here, for datetime or netcdf4 or pathlib. And it'll just install the latest version that's available. But if you want to be certain about which version of these packages are installed, they'll either be like automatically done if you use that code, the pip freeze, and then like greater than sign requirements.txt. But if it doesn't automatically add everything in here, or you want to modify things or add new packages, you can do that manually and just create a new line and then add that package. And the biggest thing I'll mention, the difference between these two files, the description file for R and the requirements text file, is that for R, the packages are separated by commas on each line, whereas for requirements, there are no commas. And this gave me headaches in the past where I didn't have a comma in my description file, and it kind of like broke things, and I couldn't figure out what was going on. And it's really easy to overlook. So if you do go this route, just be careful. But again, there are other ways you can install R packages that tend to be simpler. So that's kind of what I tend to use now more than necessarily a description file. Okay. Again, sorry for MATLAB users, but a lot of this is more focused for our dependencies for R and Python folks. Okay, so that's talking about how we would specify which packages or which dependencies to use. Now let's include them in a workflow file. So again, a lot of this top matter, like I mentioned before, is going to be almost identical. So we have a name, in this case, include our dependencies. Otherwise, we're triggering this workflow when we push to the main branch. For jobs, we're calling this particular job r_deps for our dependencies. Then all the same stuff, we're using an Ubuntu runner. We're using this checkout action. We're installing R with this pre-made action. Another option with this, and if you don't necessarily want to change the version, but let's say you want to install a package that's not available on CRAN. You could specify this, like let's say it's from the RUniverse repo. Somebody's RUniverse repo, that's where you want to install this package from. You would then give this option under extra repositories and then add that URL here. And then beneath that, now once all R is installed, we can install these dependencies of these packages using this action. So this is the simpler kind of route to go with this setup-r-dependencies action, version 2 in this case. And this will auto-detect which packages you're loading in from your scripts. If you write like library, whatever, tidyverse, or library dplyr, it'll detect those and install them here, and it'll install the latest version. So additional options, let's say you want to use things that aren't explicitly defined in your R scripts in the repo, you would then specify for extra packages the name of what it is you want to install. And this could be possible for R packages from GitHub. So in particular, I do a lot of mapping, and I use the R Natural Earth package to do that for getting like just spatial vector layers of countries and states and things like that. And if you want higher resolution versions, there's different versions of this package, but to get the higher resolution versions, you have to use this particular package, which isn't on CRAN, but it is on GitHub. So you have to specify the username for that GitHub account with the / and then the name of the repo, like if you're using the install_GitHub function from the remotes or DevTools packages. So that's how you would specify that there if you want to install a package from GitHub. And one other thing I'll mention here for the syntax that's kind of new is after this extra packages arguments, I have this vertical bar here. And that's essentially denoting that I'm going to add more code on subsequent lines. That could be one or more lines kind of down. So this is really helpful if you have multiple lines of code that you want to include, not all in the same line that gets like wrapped around and hard to read. So in this case, it's only a single line, so I didn't need to do that, but it makes it kind of easier to look at. So that's what the vertical bar means, is like you're gonna have more code beneath this. So like look for that. Okay, I saw there's a comment in the chat. So from Kurt, with the syntax and the YAML change for accessing pre-made actions on a GitHub Enterprise repo. It should not. So if you're using GitHub Enterprise, everything here, all the syntax should be the same. Unless there's some kind of weird permissions thing. Like if it was a private repo, I could see there maybe being a problem. But if it's a public repo, it should just work like how this is specified here. So if you try using that and it runs into problems, then let me know, because that would be good to know for trying to troubleshoot that in the future. Yeah.
Yeah, thanks, Josh. I was just wondering because, like, the URL has a /orgs usually for GitHub Enterprise, or it can have a. I just didn't know if we had to add that to the kind of relative path that because it looks like the syntax is the user / whatever the repo is.
Yeah, I would say kind of like whatever is standard for, especially if you were to install like an R package from your computer. If you already have like code to do that, it would be the same as whatever. But that would be, and then you might need to add a different piece in there if that's not working. Just the first way you go about it.
Okay, thanks. I'll try it out.
All right. I know I'm running behind. It's about 1:15. We have about 45 minutes left, so I'm gonna try to speed along and might need to skip some stuff at the end, but we'll see how we go. Okay, so that's for pre-made actions. But like I mentioned, we can also just run like commands from the shell. So essentially just commands from the terminal that are already in use in other cases. So kind of the default one that tends to be used most often is bash. And that's primarily for Unix systems, so like Linux and Mac. However, for Windows users, the most common shell tends to be this PowerShell core. And each of these have their own syntax and stuff. So whatever I use for like Ubuntu for Linux might not work even for Mac, but definitely wouldn't work for Windows. So just keep that in mind if you are using like commands for a particular shell. Is they are going to be different probably across these different operating systems and specific shells like Bash versus Z shell versus PowerShell. So I have some simple examples of how you can do that here. And then we go into more kind of relevant examples. So in this particular case, let's say we want to explore the directory structure and storage for our virtual machine. Because like, let's say maybe that's important, or we want to double check something to see if files are really there, or different relative paths for files. So we have this YAML file here. And now for our event trigger, we have a new one called workflow dispatch, which I'll show in a second. And then beneath that, we're defining the job. So we're calling the job debug. We still have it running on Ubuntu. We're starting with our checkout action. And then beneath that, we have this step called, that I'm naming print directory tree and check disk space. Since I've run into issues in the past with running out of storage space on this virtual machine. So here I'm explicitly naming or calling which shell I want to use, in this case bash, for again, born again shell, which tends to be the most common or popular. And then after that we have these curly brackets, curly braces, and then a 0 in there. And that's essentially acting as a placeholder for any commands that would follow it. Isn't necessarily always required, but could be good practice to include that. And then beneath that, we have the run arguments, and then like I mentioned before, a vertical bar, and that allows us to use code or commands on multiple lines, as long as they're indented. So I'm using this one command called tree that prints out a directory tree, and then beneath that, I'm using this other command that's essentially going to show the disk storage that's available from this Ubuntu runner. And I have some screenshots of that below, but this might be a good use case to actually run this live. So I'll click on this. So this file is called bash_debug. So I'll click on that here. And I've run this in the past and it's been successful. But I'll talk about this in a second, but I can manually run this if I wanted to directly from the GitHub website. So if you run that, I'm going to refresh the page, and now you see that this is like this amber circle, and that means this is in progress. So I'm going to click on it, and we see now that it's spinning. It's telling me this. Oh, I already finished. 7 seconds. So if I click on this and expand it, so this first part, it's setting up the job. So we have info about the runner itself here. So like the operating system is Ubuntu. Info about checking out the repo. So pulling in all the files. And then here is the directory tree. And there's just a lot of stuff here because this directory, this repo is holding all the files and images for the website. So there's just a lot of stuff. So we have this entire directory tree, which is pretty big. And then at the very bottom is the disk storage or disk usage. And the one that only really matters is this top line, the dev root. So it says there's about 72 gigs of just total storage space, and we've already used 54. There's 18 left available, so that means there's 76% being used. So if you're potentially running into issues, like this could be a good way to just see what things look like on your virtual machine, because it's a lot harder to do this versus your own personal computer. Okay, so that's just kind of basic usage of these commands for the shell. And this is just what I showed on the website there. And then again, this warning that these commands will likely differ depending on the shell and the operating system. But let's say you want to use these commands to install software. So there's not maybe like a pre-made action for it, but you need to use these commands to install things that you want to use. So some common examples are installing geospatial, like lower level libraries like GDAL. This can be used for Python or MATLAB or R. Additionally, you may be interested in installing let's say a package that isn't available on CRAN or GitHub or pip or something like that. So there's options to install that from the command line. And additionally, if you want to install other software, so for those that might be using Copernicus Marine Environmental Monitoring System or Service Data or CMEMS, you need to use the Copernicus Marine Toolbox software. So I show how to install that. And same for those that handle large netcdf files. I show how to install CDO on the cloud, basically. All right, so this Copernicus example, the CMEMS dataset or software, I'm giving it, again, this name at the top, install Copernicus Marine Toolbox. I'm defining the event trigger here, which is essentially just a manual trigger that I click a button and it runs. I'm naming install X for install example as the job name. And now I'm showing an example here where I'm using Windows instead of Ubuntu. Just for the sake of it, not like it's really necessary in this case. I'm doing the checkout for the repo. I'm installing Conda, like I showed earlier. And I'm also specifying the specific channels for Conda that I would want to use. And then beneath that, now I'm installing the Copernicus Marine Toolbox. So I'm specifying the shell, again, using bash, and making this a little more robust with this -el flag. And then beneath that, the commands to install first Copernicus Marine, so the Copernicus Marine Toolbox software from the Conda Forge channel. And then it also relies on SciPy, the SciPy package, which isn't apparently a dependency that's automatically installed. So you need to install that separately, which is weird. So this shows that you just run a new line and install SciPy separately. And then to check that it actually installed properly and it's there in the cloud on this virtual machine, I added a new step. So I'm using the Copernicus Marine command for the software and then versions. I want to just check what the version is. And that would print all this stuff out. So to see, hopefully this, it's relatively quick. I can click this to trigger. And again, when I click that, it doesn't show up automatically, but it brings up this essentially banner that says workflow dispatch event trigger. But if I refresh the page, now I see that it's running. So if I click on it and then on that job, this is the live log. So we can see this thing like running in real time essentially. So right now at the moment, it's already set up the job, the runner, checked out the repository, and now it's installing Conda. So occasionally it gives these warnings. It's not an issue. I wouldn't worry about it. But it's printing out all this stuff. And sometimes like the printout gets like super long and it takes forever to scroll up and down if that's something you want to check. But it'll continue to print out all of this stuff. So at least it makes it a little bit easier for debugging things because you have a lot of stuff you can parse through potentially. You can also get buried in it. But again, because this is in the cloud, this is just happening. So you don't need to necessarily monitor this if you didn't want to. I'm just showing it for the sake of showing what this looks like for a workflow that's not just like 7 seconds long. So here it's installing all these Python packages and listing them all out. And sometimes it is a bit redundant. So for this, I'm installing Conda and it's installing all these things. The next step, I'm installing Copernicus Marine Toolbox. A lot of the dependencies that it installs are going to overlap. So it'll try to install all these packages that already exist, which is kind of a waste of time, but there's nothing you can really do about it. And the thing about the GitHub actions that's both good and sometimes frustrating is that essentially it starts with a fresh install or fresh virtual machine every time, which means that it's highly reproducible because there's not just like lingering stuff on there that you can't figure out how it's set up. But that means that every time you want to do something, it needs to install all of this other stuff that you want every time. Sometimes, depending on what you're doing, that can be relatively quick. It might be 30 seconds. It might be 5 minutes. There's other GitHub actions I've created where it takes like an hour. And let's say it fails at like minute 48 and you got to run the whole thing over again to debug what's going on. It gets super frustrating. So just something to keep in mind is that it starts fresh. There's no persistent storage on this. The persistent storage is your GitHub repo. So that's where all your files should be, but everything that's like on this virtual machine essentially goes away the second it's completed or fails. So just something to keep in mind. All right, so it's almost done installing Copernicus Marine Toolbox, and then the last thing it's going to do is check the version of it just to ensure that it's working and it shows me this information. I think the latest version is 2.2.2, if I remember correctly. So that's what it should show in a second here, hopefully. But again, yeah, it's taking a little bit of time. But yeah, it's really easy to waste a lot of time waiting for these things to run as you're debugging them because it almost never works on the first attempt. So if it takes a while to fail, that means it's going to take even longer to get something working, unfortunately. Okay, so it just installed SciPy, and then here, okay, now it's all this other stuff here at the end is like it's cleaning up the workspace for another person to use this virtual machine, essentially. So I'm going to need to I'll condense these so I can see the end. So it worked, and the latest version is 2.2.5. So that's the latest version that's available, and it's installed on this machine. So that took 4 minutes. So that's not terrible, but again, something to keep in mind as you're doing stuff. All right, so that's how you would install Copernicus Marine Toolbox. As one example, another example for installing other software from the command line, I show how to install GDAL and CDO. So the beginning part, again, is basically the same as everything we've seen, but the second step of this job, I'm now doing some other stuff using syntax that's specific to Linux in particular. So I'm using this sudo command, which is essentially an abbreviated version of super user do. So this just means that like you're getting like all the permissions you need to just change stuff on the machine. Because without that, it might not let you do stuff because you don't have like the correct permissions. So in most cases, if you're like installing different things, you may need to start with the sudo command if you're on a Linux runner. Then next use this apt-get command that basically just like tells it to like pull packages from like the appropriate repository, and you typically start with update. So you just update whatever is needed for your system. If you don't run that, a lot of times you won't be able to install what you actually want to install. So you kind of have to start with this command, sudo apt-get update. And then after that is when you run your command to actually install the packages, that the software you want. So in this case, I'm using sudo apt-get install and then listing all these different geospatial libraries that are typically relevant. So there's GDAL, and then there's other stuff like Geos and Proj and SQLite and UD units, other stuff. So that's primarily what you would need if you're doing any kind of raster or vector geospatial work. And it's not installed for you by default. You can use like that command essentially. And then next, beneath that, I have another step where I'm installing the CDO tool and just using the simple single line command. So sudo apt-get install CDO, and then that's it. And then beneath that, just checking to make sure that this worked correctly, I'm running these commands to check the version of each of these software. So checking the version of GDAL and then checking the version of CDO. So I'm not going to run this workflow because that'll take some time, but just showing the results of that. So it starts off condensed here, but if I expand this check software versions, we see that we installed GDAL 3.8.4, and then for CDO, we have version 2.4.0. So both of these are working correctly, so that's good. And then we could use these in subsequent steps if we wanted to. I'm going to skip this in-law example because we're running out of time, and that's probably not relevant to just about everybody here. All right, so that covers just adding steps for either pre-made actions or custom kind of commands from the terminal. But we haven't covered scripts or anything yet, which we'll get to in a little bit. But next, I wanted to briefly cover events, so triggering events. And because there's only 30 minutes left, if you have any questions at this point, just add them in the chat and I'll answer them as needed, or raise your hand. But I'm going to try to really speed through some of this stuff to hit the highlights. So this is the last like basics section of like what types of triggers can you use to run a workflow. And there's a whole list of these that are linked here on these GitHub docs. But again, the most common ones that you probably would need are either pushing to a repo, using a schedule. So you're scheduling when these are going to run, either based on a certain time or time of day or frequency, or you're using what's called workflow dispatch, which I showed a little bit ago. And that's essentially just a manual trigger. So a button's available for you to click, and that'll just run the workflow for you. And each of these have their benefits. There's certain instances where they may be useful. So let's say you make changes to code or to other stuff, and whenever you push it, you want that to trigger a workflow to run. Additionally, maybe you don't make many changes, or you want stuff to run daily or every 30 minutes or something else. You want that on a schedule. So like, let's say maybe that's even once a week. And then in the meantime, you still want it to update if there's a change, so you have it on a push as well. But maybe you didn't make a change, but you still want it to run, then you can have this manual workflow dispatch trigger. So that's another option. And then like Isaac was asking previously, you can even have GitHub Actions workflows trigger other workflows. So I have here for this note, you can have the completion of a workflow as a trigger, and you can even kind of configure this in a way where the outcome will depend on the success or failure of that preceding workflow. So there's a lot of options at your disposal here. So I briefly provide info on each of these four different triggers or events that I talked about. I'm going to try to just breeze through these just because of limits on time. So this code example here, I have this name, push or pull request is the name of this workflow, and that's because here for on, I'm defining two events. In square brackets, I'm listing two in this case. So I have push and then a comma and then pull request. So if you're not familiar with pull requests, it's more of like trying to like make changes to a GitHub repo that requires some form of review essentially beforehand, before like making them officially part of that repo. So unless you're doing software development, you're probably not going to be using it that often, if at all. But here, just wanted to note that we're using this bracket notation to include multiple events on a single line here. Additionally, we can do the same exact thing in a different syntax. So instead of the single line with the bracket notation, we can add these on multiple lines and then have these indented under on. So we have push and then pull request underneath. And you need to make sure that you have a colon at the end of each of these lines. Otherwise, the workflow is going to fail. And that's just the syntax that's used when you set it up this way. So if you have this in the brackets on one line, you don't need colons. You just separate them with a comma. If you have these on separate lines, which you typically only really need to do if you like have more info. So like on push, and then you want to specify the branch. Or a pull request, then like it might give you other options. That's more of probably when you would need to set it up this way, but you can do whatever you want. And everything beneath this is just like boilerplate just to put something there. So in this case, it's just checking out the repo and printing a directory tree. So that's not as important as, in this case, the event triggers that I wanted to highlight. Next is probably something that a lot of people would find really useful. This was something I was trying to accomplish for a while for some of my own stuff and couldn't figure out how to do until GitHub Actions was actually like released and created. So this allows you to essentially operationalize and like run stuff on your own in the cloud from your GitHub repo without needing other systems set up essentially. So what you would do is essentially define a cron job. So you use a certain syntax to define the frequency or the times when you want this workflow to trigger. So this could be, let's say you want it to run every 5 minutes or once a week, or at 6:30 a.m. every day, or something to that effect. You can specify that using this particular POSIX cron syntax. And it's definitely confusing to set up and figure out how to do this properly. So I recommend using one of these websites, CronHub or Croniter, and that'll basically let you write stuff and it'll kind of tell you what that means. So in this case, this is the syntax for running a workflow every 5 minutes. But let's say you wanted to run this every 5 hours. I would now move that to this spot. Now it's saying every minute, every 5 hours, so I would change this first one to a 0. So at the top of the hour, every 5 hours, this will be triggered. And it gives you some information here of different ways you can set this up. But this at least helps you with setting up like what the syntax should be. I have some caveats here. The main one being that the times you specify are all referenced to UTC. So at Greenwich Mean Time, essentially. So because we just started standard time a little bit ago, these are all, we're on standard time. So for Eastern time zones like me, I'm 5 hours behind UTC. So that would mean for Pacific time, you're 8 hours behind UTC. So if you want something to run at 6 a.m. Pacific, you need to add 8 hours. So that would be 2 p.m. UTC. So that would be essentially a 14 in that second slot for the hours, is how you would set that up. So an example here, I'm showing that again for this on arguments, I'm using schedule, and that's telling it I want to run a cron job. So I want to run this workflow on a schedule, and then giving it the info here. So it's an indent and then a dash, cron with a colon, and then our syntax for the cron job. And you want to make sure that these are in quotes because asterisks are a special character for YAML. So just make sure that these are in quotes when you add this in. And everything else beneath this is the same as the previous example. So now instead of on a push or a pull request, this is going to run every hour, essentially, is what this syntax is set up to be. Every hour at the top of the hour. All right. So if we wanted to run this every 10 minutes, this is the syntax we would have for running it every 10 minutes. Alternatively, if we want this to be a little more complex, so in this example, I'm saying if we want this workflow to run Monday mornings at 9:15 a.m. Eastern Daylight Time, specifically, this is the syntax we could use. So the 15 in the first spot, so that's the number of minutes after the hour. 13 in the second spot, so that's the number of hours from the beginning of the day. So that's for daylight time. If we want this to be 9:15 a.m. Eastern Standard Time, this needs to be a 14 now. Then we have these two asterisks, two stars here. And then now we have the day of the week in the last slot. And let's say we only want this to run on Mondays. So you can specify the 3-letter abbreviation here, or the numeric form of what day of the week it is in its place. And again, everything beneath this doesn't really matter for this case. We're just showing how to set up this scheduled workflow. Moving on to manual workflow triggers, like I was showing before. This is using what's called a workflow dispatch. So in this particular case, I'm showing how you can use a bunch of different types of triggers, a bunch of different events. So we have our on arguments, and then we're saying on a push, on a schedule, so for this particular cron job, or on a workflow dispatch, so on a manual trigger, we can run this job, essentially. So this is really convenient when you want the flexibility of maybe having something on a schedule or having something be on a push event, but you also want the flexibility of just being able to run this from the browser whenever you want, especially for debugging, which is really helpful. A lot of cases where bare minimum, you want one of these, like a push or a schedule, and then almost always I include a workflow dispatch trigger. And I think I showed what that looked like before, but you would navigate to your Actions tab here. So from your repo, you click on the Actions tab, and then whichever of these workflows you want to use. And this one actually doesn't have a manual trigger. If I go to this one, the check repo size and structure, that one does. So I click that button and then click run workflow. And then again, just make sure that, it'll say here, workflow run was successfully requested. You don't see it, but you need to refresh your page and then it'll show up. So that's how you would make sure you can check it while it's running. Okay. And then the last event that I wanted to cover is, instead of workflow dispatch, is workflow run. So this is what you use if you want a workflow to trigger another workflow. And again, I'm not going to really provide guidelines as to how to break up your steps in your workflow into different jobs or different workflows themselves. This is just showing how you would write the YAML code to do it. Because that's a separate idea based on your concept of how things are running. So the first example, the first YAML file shown here is the very first one that I showed you at the beginning. It's just a simple event trigger on push. We have this simple job where it's listing all the files from the root directory in the repo. We have a separate workflow file here, simple5a, where the on arguments, the event here is workflow run, like I mentioned, so different from workflow dispatch. And then one of the options for workflow run is we need to specify which workflows are going to trigger this one to run. So in this case, I want this simple YAML file to trigger it, but the name I'm giving it is test.gha. So that's what I'm providing on this line to workflows is test.gha. And that'll basically identify that whenever this finishes, I want this one to run. And then we can also specify the type. It's like the status of that previous workflow. So here, the different options you have are either completed, requested, or in progress. So there may be instances where it could make sense to use requested or in progress. I just haven't found one yet. So I've only been using completed. So whenever a workflow completes, then I have it run this other stuff. So if this first workflow just, again, these are simple examples, so this wouldn't be necessary, but just showing how it works. If this lists all the files, This one then triggers it and then prints the directory tree. So that's if it completes, but it doesn't rely on that status of the completion. It could have failed and it's still going to run this thing. But maybe you don't want it to run if it failed. You only want it to run if it succeeded. You could set this up also to account for that. So you wouldn't need to change this first file. You would leave this stuff at the top of the second file the same to trigger it, but you would change the stuff under the job itself. So under jobs, the first job I'm specifying here is on success. That's the name. I'm having it run on Ubuntu, and then now I'm giving it this conditional statement if, and it uses kind of this boilerplate syntax that's available, but basically saying if this previous run was successful, then do these steps. In this case, I want to use the echo command on the terminal. So print the text, the triggering workflow passed. But in general, you'd probably have it run commands and run scripts and things. Additionally, there's a second job that's run simultaneously, also on Ubuntu, but it detects if this workflow failed, then print this text that says triggering workflow failed. So that's how you would set this up if you want the outcome, the workflow to differ based on the status of that first workflow. All right, that is basically it for this component for like the basics, which I spent way too much time on. So I will move on to the complex part of this and try to speed through that. But I'll briefly pause for any questions before I kind of get to the more relevant examples of like showing use cases of how to run your code and do other stuff. Okay, well then I will press on. Oh, I see something in the chat. Per Kurt, does GitHub send an email notification? Yes. So I didn't mention that earlier, but I think either on the basics page or the anatomy of a GitHub Actions page, I have some text basically saying if your GitHub action fails, you will automatically get an email notification that it failed. It'll tell you information like how long it took to fail, and then give you a link that'll redirect you directly to the live log and show you exactly where it failed. So actually let me try to pull that up really quick because I've been getting a bunch of these recently, unfortunately, and I just delete them. But yeah, so here's one. So this is what it would look like. It'll tell you like your username, the actual repo name, the name of the workflow, MATLAB example. And then in this case, I have multiple jobs. So the first job was successful. It took 3 minutes, 8 seconds, but the second one failed. So you could click on this and then it would bring up the workflow. So I see the first job was successful, the second one failed. And I can click on that and it'll open up right to where it failed. So it was rendering the website, this Corda website, and it got to one step on one of the pages for accessing ERDAP chlorophyll data from this one product, and it wasn't available. So it just the whole job failed in this case to render the website. So that's what you would find essentially. But it's super valuable. Ideally, when you have stuff that doesn't fail regularly or you want to be notified immediately, this will tell you that. If you're getting these every day, it gets kind of annoying, but it's at least very informative and lets you know. Yeah. So that's the defaults. There, you can go into your settings and like change it so you don't get notified every time if it gets too annoying for you. But that's the default setting is to inform you, which is nice. Okay. So now moving on to stuff about running your actual scripts and using secrets. So using credentials and tokens and things like that. All right. So we've covered all the basics of just setting up a workflow action file. But now we might want to run our actual code, which is a simple extension, or we want to provide credentials that allow us to push to the repo, to use an API, to access a database or other things. So for this first set of examples, I'm showing again for each of the different programming languages, R, Python, and MATLAB. but these are all doing the same thing. So I'm trying to show the same exact example, just in each language. So these are all parallel to each other. So the first example here in R, on this trigger workflow dispatch, so again, that's a manual trigger that this is run. I have this job named run R, starting with Ubuntu. I'm doing a checkout action, installing R, installing the R packages. One thing that's really nice is using caching, and that speeds up this process a lot. If your packages take a while to install, if you specify caching, especially cache always, that means if the job runs but fails at the end, then all the packages you installed initially before it failed will still be there. So you don't need to spend time. Like sometimes it takes 30 minutes or more, depending on how many packages you have, if they need to compile to see, all kinds of stuff. It can take a really long time just to find out your workflow failed. So if you use caching, even if it fails, it'll still have it saved. It'll make it like take 30 seconds instead of 30 minutes, which is great. So specifying stuff for installing packages, and then now at the very bottom here, running the R script that we created. It could be anything, it could be more than one script. So in this case, I'm giving the step here the name download and export sea surface temperature. I'm specifying the shell that I want to run. So before I was saying bash, because I was doing commands from the terminal, just bash shell. In this case, I want to run R code. So I'm specifying the script, or the shell is R script. And then here again, the syntax as like a placeholder for whatever R code is going to come after it. So beneath that, using run, I'm using the source function from R. So everything here is R code. And now I'm giving it the full file path to that R script. Just to show what that looks like, I'll click on this here. I'm not going to go into super detail. It's a super short script. But essentially, it's accessing ERDAP data for sea surface temperature for a particular day from yesterday, and then exporting this as a netcdf file for the Mid-Atlantic Bight. That's it. All right, so doing the exact same thing in Python now. It's going to look very similar. So in this case, we're installing Conda. And then to install the Python packages, because I don't think we covered that before, we're using that requirements file. So for this run arguments, we're using pip install, and then this -r flag, and then the requirements file. So requirements.txt. And supposedly the -r is to make sure to tell it to run each line of this requirements file to like install all of these packages individually, which may cause an error if you don't have it. And then once the packages are installed, then we can run the Python script. So in this case, the same thing as for R, I have the same almost identical Python script. So here for run, we use the Python commands and then the full file path. And it's, again, like I mentioned, doing the exact same thing. So if I click on this Python script, I'm loading in the date, time, and Xarray packages. I'm specifying yesterday's date. Using Xarray, I'm reading in that sea surface temperature data and then subsetting it for a particular time and spatial extent, and then exporting it as a netcdf. So doing the same thing just now in Python. And then lastly for MATLAB, again, very similar. So we're doing this manual trigger, this workflow dispatch. We're installing and setting up MATLAB using this action. And then to run MATLAB scripts from this virtual machine, from the workflow, we're specifying this action here. So MATLAB-actions run command. And this is going to differ from like Python and R, where we're running it from like the shell from the terminal, essentially, where we have to set this up a little bit differently because MATLAB is just different in this case, where we're specifying this with argument for different options. And here's where we supply command. So after command is where we add our code, essentially, for MATLAB. Because my MATLAB scripts I'm using are in a subdirectory from the root directory, I need to specify the file path. Otherwise, it's not going to work for whatever reason. And I guess there's a couple ways to do this. So the way that I'm using here for this example is this add path function. And then I'm supplying the folders above the actual file itself. So complex GitHub actions /source. And then comma, and then the file name without the extension for whatever reason. I don't understand why, but this is what works for running a MATLAB script, especially one that isn't a subdirectory. If it's in the root directory, you can skip that first part. You just give it this file name without the extension. So that's how you'd run a single script. And beneath this, let's say you want to run multiple scripts at a time in this single step. You could do that. You could do multiple steps if you wanted to, but that's probably unnecessary. So to do this in a single step, the only difference for MATLAB is that you just add a comma and at the end add your new script name. So in this case, this is summarize SST. So going over to that file here, this is the MATLAB script for summarize SST. You're reading in this netcdf file and then using the summary function across the whole thing. If I go up and change back to Python, so for Python now you just add a new line. So you use the Python command at the beginning and then the full file path. And then very similar for R, you just add a new line and you source another R script. That's it. So pretty simple to run one or more scripts at a time, regardless of programming language. For secrets and tokens, I'm going to go through this pretty quick, but basically if you want to make any changes to your repo, like committing and pushing files, you need a GitHub personal access token or PAT. And if you haven't created one before, what you would need to do is I have some instructions here and screenshots where you go to the settings page here for this is for creating just a secret. So let's say you have like credentials you want to save, so they're not hard coded. So under your repo, you go to the settings tab and then go to the sidebar on that page down to secrets and variables and then click on actions. And then on that page, you click on this green button, new repository secrets, and then you enter your info there. So if I was to do that on this repo to show what I have a few different secrets available. So I have one token, and then I have some credentials like a password and a username to use the Copernicus Marine Toolbox. So you would store these here, and then you call it based on these names to then use those saved values. But they're not going to be exposed to other people. So even if this is a public repo, someone can't just like steal your credentials and access stuff on your behalf. So that makes it definitely more secure. So that's for just general secrets. So for doing this with Copernicus Marine Toolbox, I already showed these steps before for installing it. So beneath it, going further down, I'm installing R and R packages that I need for this particular case. So I'm reading in, downloading CMEMS data from R. And here on this last step, I'm calling download CMEMS data. I am defining environmental variables with this env arguments. So here I have one variable called Copernicus Marine Service username, and this is the syntax I'm using. So like $, double brackets, secrets, all lowercase, dot, and then the name of the secret. So like I showed before here, I'm just giving the values in the environment the same as the secrets themselves. So I'm giving my credentials to access this API. And then beneath that, I say I want it to run an R script, so I'm using the R shell, and then sourcing this R file to download CMEMS data. So I have some more info on that here, along with the associated R scripts. There's also apparently a Copernicus Marine R package if you want to try to access that data that way. For Python, it's a lot easier to access that data. You don't need like separate workarounds. And then, yeah, for creating a personal access token for GitHub general stuff, you would go to the settings page for your profile, go down to the very bottom of the sidebar, click on personal access tokens and go to tokens classic, and then generate a new token. And that's what you would need to like push stuff to your repo. You might need to define like what you can do with it. And that's typically auto-detected whenever you're running things from a workflow file. So some of the important stuff that you would need to include if you're especially planning on pushing stuff to your repo from a GitHub Actions like virtual machine is Here you need to define permissions to give the environment for this job or a particular step. So I'm saying for permissions under this job, I wanted to give the permissions for the contents to write to them. So I'm going to be able to write stuff to this repo. And I'm also defining here environmental variables. I'm giving it that personal access token that I've stored. Going further down at the very end, the last step, I'm committing and pushing changes. So I've downloaded C service temp data using Python code to access ERDAP data products. Now I want to push this to the repo. So like you do when you first set up your kind of environment for setting up your GitHub or your Git credentials, you need to give your username and email. And you can use this syntax to like have it work on your behalf without like hard coding in your username or your email. And then just normal Git code. So git add dot or git add period, which means add or stage everything that's new or changed. Then I'm committing with this message. So add new ERDAP C service temp file, and then pushing these changes to my repo. So that's how you could use a GitHub token to push changes back to your repo that otherwise wouldn't be seen. All right, I think I'm gonna have to leave it there because we're just about out of time, but I'm gonna use the last couple minutes to answer questions and then just show you what is available throughout the rest of the website I didn't have time to cover. So I have another subsequent page on running multiple jobs in a workflow, whether concurrently or sequentially, and showing how you would set that up. I also have another way of like kind of passing data between jobs. So you can either commit and push stuff to your repo and then read it back into another job or workflow, or you can use what are called artifacts to essentially store objects that are more or less temporary. So especially for intermediate products that you don't want to like save, but you want to be able to use. In the short term, that's a nice way to do it, is with artifacts. So I show some examples with that here. And then lastly, for maybe only one person, if you're interested in R package developments, you can automate a lot of these different checks and tests with GitHub Actions, primarily to use this package. So I show some examples of how to set stuff up for running R checks on packages and checking code coverage, things like that, based on some experience I have with my own R package development. All right, so that is it. Again, if you want to ask questions in the future or have other stuff you want to bring up, feel free to go to this discussions page, this forum for the repo, and just post stuff in there, and I'll try to answer them as I can. All right. Let me go through the comments. I'm going to stop sharing my screen for now. But yeah, I'm happy to stay on as long as people are here and want to ask questions. So Isaac, I see you asked a question about upload, download data from a Google Drive. It's definitely possible to obviously access Google Drive from Python or R, but in general, I would say just using a GitHub repo because it's all in one place and it just makes things easier. So like unless you can't for some reason, you can obviously still do this and access Google Drive with your code, but that would be my suggestion, is to try to put stuff on the GitHub repo or somewhere that you can call programmatically and then move stuff around. So that'd be my suggestion.